Lesson 4, page 633, solving systems by elimination. So what we have seen before is you can substitute one variable by isolating for it first and then dropping in the expression. So today we're going to learn a different method of solving by elimination. So we have a system here of two equations and they're asking us to solve it. So the process of elimination says that we can actually add the two equations to eliminate y. What do I mean by that? Well, if you just add the top and the bottom, 2x plus 3x, you're going to end up with 5x. If you add 7y minus 7y, then you're going to end up with 0y, so we don't even have to write that. And then 13 plus 2 is 15. So the magical thing that happens is that if you add these two equations, the y just drops out. And you can use this equation to solve for x. X equals 3. And then we can go back and solve for our y afterwards. So you can use either this equation or this one, doesn't really matter. I guess I'll just use the top one. So 2 times 3 plus 7y is equal to 13. 6 plus 7y is equal to 13. We can minus 6 from both sides. You end up with 7y is equal to 7 and y is equal to 1. So your final answer then would be that x is 3 and y is 1. I'm not going to go through and verify that here, but you can either verify using a graphing calculator or you can verify by plugging it back in, making sure the left side equals the right side. Now, if you're anything like me, you might say, wait, you can just add equations. How is that legal? Why is that allowed? Well, remember that if you're trying to solve any equation, you can do the same thing to the left side and the right side. And anything you want, you can do, so long as you do the same thing to the left and the right. So if I add 2 to the right side of the equation, I must also add 2 to the left side of the equation. But this actually equals to 2. So whether I add 2 or whether I add this entire expression, it's the same thing because it told me that these two are the same thing. So in a very sneaky way, what you are doing is adding the same thing to both sides of the equation. Another way you can do this is if you want to subtract the equation. So for example, if I look at this system and I decide that I want to add the system, I'm going to realize that we have a problem because if you add 4x and 4x, you're going to end up with 2x and 2x, you're going to end up with 4x. And then you have not successfully eliminated a variable. We still have two variables, and that's not helpful. So we want to eliminate one of the variables, actually make it drop out. So in this case, instead of adding the two equations, I want to make x disappear. So I can actually subtract the second equation from the first equation. So 2x minus 2x is equal to 0x. 6y minus 3y is 3y. And 6 minus 4.5 is equal to 1.5. So now we have 0 x's, which we don't even have to write. 3y is equal to 1.5. And we can divide 1.5 divided by 3, which is 1/2 or 0.5. And then we can go back and find x by plugging into the equation of our choice. So I'll just choose the first one. They look equally easy to me. 6 times 0.5 is equal to 6. 2x plus 3 is 6, like so. And x is equal to 3/2. Now, because they've given us decimals, I feel pretty okay giving them decimals back. And here would be my final answer. So the moral of the story is, when you are choosing whether you add or subtract, you want to be strategic because you're trying to make one of your variables disappear. So you want to look for a matching term, and then you either add or subtract it based on whether that one will disappear or not. The one issue, though, that I find with subtraction is that a lot of students forget to subtract because the subtraction sign is written out here. So some students choose to change all the signs in here and in here to make sure that they don't accidentally add partway through. So we're looking at this system in this case, and we're asked to solve it by elimination, which means to add or subtract in order to make one variable disappear. But does adding or subtracting the equations eliminate either of the variables? Well, if you look at x, If you add these, you're going to get 6x. And if you subtract them, you'll get negative 2x or 2x. And these ones don't match either. So if you don't have some kind of a matching term, you're not going to be able to add or subtract to eliminate the variable. But we do have a way around this. We can multiply the second equation by 3 and then add the two equations. So what that means is I can actually just multiply this by 3. So if I do that, I'll have 12x minus 3y is equal to 66. And what that does is it makes it so that I have a matching term with this 3y. So I'll write the red equation underneath. And you can feel free to switch the equations. It doesn't matter which one you write on top or the bottom. Whichever one suits your purposes is totally fine. So then you have to decide, do we want to add these equations or do we want to subtract them? Well, it looks like these are opposites. So to make them disappear, all we have to do is add the equations. So we will add them. So 12 plus 2 is 14x. These two will disappear. And then we will have 70 divided by 14. And we're going to end up with x is equal to 5. And then we have to go back and find y. I'm actually going to choose this bottom equation because y is already isolated. I think it might make my life a little easier. So 4 times 5 minus y is equal to 22. 20 minus y is 22. I can subtract 20 from both sides. Negative y is 2. So y is equal to 2. So when we give our final answer, we make sure that we give the x value as well as the y value. You could also give this as an ordered pair if you would like, 5, 2. And you could put that in a graphing calculator to verify. But if we take a step back and look at what we just did, we always have to ask ourselves, wait, was this even legal? Can I just take an entire equation and multiply it by 3? Haven't I just changed the equation? Well, remember, what does multiplying an entire equation by 3 mean? It means that I have multiplied every term by 3. So if I look at this original equation, it is equivalent to this equation. And I haven't broken any equation solving rules because I'm allowed to do the same thing to both sides. And the same thing that I've done is multiplied by 3. So this is totally legal to multiply both sides by whatever you want, so long as you multiply both sides. Now, some students might say, wasn't there another way to solve this equation? Is there, in part D, multiply the first equation by an appropriate number, which will eliminate x by addition or subtraction? So the case that we did, as you can see over here, we eliminated y. We caused the y term to drop out. But could we redo this equation by eliminating x instead? So if I want to try and make my x terms match, then I could multiply this entire first equation by 2. If I do that, then I'll have 4x and they're going to match. But I believe that what would be even better would be multiplying it by negative 2. Because if you have negative 4 and positive 4, then you can add them together and you don't have to worry about making a mistake by subtraction. So whenever I have the choice, I always try to make sure that the terms that I'm trying to match up are the opposite of each other. So we have negative 2 times 2x is equal to 4x. And notice how I've applied the negative 2 to every term on the left and on the right. If you do this, then actually you can add the two equations and your x term will drop out. So you'll end up with negative 7y is equal to 14. And you can see again that y is equal to negative 2, which is exactly the same thing that we found here. Sorry, negative 2, negative 2. So actually, if I take a step back here, yeah. In the next class example, we have a more difficult equation where it's not easy to see whether we should eliminate A or eliminate B. So in part A, it's asking us to choose appropriate whole numbers to multiply each equation so that the system can be solved by eliminating B. So they're telling us specifically that they want us to eliminate B. So this B is not an easy multiple of that B. It's not going to be easy, but it's still possible. What we have to do then is multiply both of the equations by different things to try and make it shake out to the same thing. So I can actually multiply the top by 7 and the bottom by 3. It will always work if you multiply by each other, but sometimes you can think of easier numbers to make the multiply out. So if I want to do that, then I can see in the top 35a plus 21b is equal to 21. And in the bottom, 9a minus 21b is equal to 243. So we have a really good situation now because not only do we have a matching term 21 and 21, but they are actually opposites, positive and negative. And I really prefer doing that rather than having them match exactly and subtract them because I think I'm less likely to make a mistake by adding. So I will add those. These get deleted. 35 plus 9 is 44, A. And 243 plus 21 is 264. So we can divide both sides by 44 to get A is equal to 6. And then we can solve for B by choosing the easier equation. I guess this one has smaller numbers, so I'll choose that one. So 5 times 6 plus 3B is equal to 3. So 30 plus 3B is equal to 3. I can subtract 30 from both sides. 3B is equal to negative 27. And so we're going to get that B is equal to negative 9. So our answer is A is 6 and B is negative 8. I'm not going to verify that. I'm going to trust you guys to do that either in your calculator or algebraically. So it says that there's another way to do it. We could choose whole appropriate numbers to multiply each equation so the system can be solved by eliminating A. So in this case, they want us to eliminate A. Sure, we can do that. We just got to backtrack and say, all right, if we want our A's to cancel out, then maybe we can multiply this one by 5 and this one by 3. That will definitely work, but then I'm going to have two matching terms, 15a and 15a. My preference is to have one be 15a and one be negative 15a so that I can just add the equations. So to do that, you just have to tack on a negative to one of them. I'll just tack on a negative here. So if I do that, then I'll have negative 15a, and I won't forget to apply the negative to the inside, minus 9b is equal to negative 9. So just to verify, if you wanted to put a negative and there was already negative, it would turn to positive, just like our distribution rules. Then in the bottom, 5 times 3 is positive 15a, minus 35b is equal to 405. So then our 15a's cancel out, and then we can add the rest. So negative 44b is equal to 396. And if we divide both sides by negative 44, you're going to get B is equal to negative 9. Now I see that there was a mistake here. There should have been negative 9 right there. Sorry, guys. So B is negative 9, and we could go back and solve for A, and it would be the same. But what I want you to see is that there's two different ways to solve the exact same equation. You could have eliminated B. You could have eliminated A. Sometimes one is easier than the other. In this case, it was a bit of a toss-up, and you're going to get the same answer either way. All right, solve this one using elimination. So we have two equations again. The difference is that this time they don't quite line up properly. Like notice if I were to write this one underneath, there's 3x equals 5y plus 26. If the equal signs do not line up, that's going to be a problem. You can't really add or subtract those two equations. It doesn't work. But there's a quick fix. All you just got to do is make sure to rearrange one of them so it looks like the other. So I guess I'll just rearrange this one. I'm going to set it equal to 0. So 3x, I'll put it over here, 3x minus 5y minus 26 is equal to 0. So we can do it that way. And then we can continue with our methods where we decide which term we want to eliminate. You either want to eliminate x or y. I guess I will just eliminate y. It doesn't look like it makes a big difference. But to do so, I'll have to multiply this by 2 and this by 5 because I'm trying to make my y terms match up. So then I'll have 20x plus 10y minus 65 equals 0. And the bottom one will be 6x minus 10y minus 52 is equal to 0. So that works out. Positive 10 and negative 10, if I can just add them together, will work to eliminate that. So 26x minus 117 equals 0. So 26x equals 117. And we're going to have x is equal to 4.5 or 9/2. And then you can go ahead and solve for y, which I'm not going to do right here. So some students might ask, I understand that I have to rearrange the equation so the equal signs match up. Does it matter then if I choose to rearrange the first one so it looks like the second one? It doesn't matter. The important thing when you're rearranging equations is that all your x's and your y's line up and the constants line up and the equal sign is in the same place. If you have that for those two equations, then you're okay. You can proceed with multiplying and adding or subtracting. So occasionally you're going to see a system that has fractions or brackets or both, and these are going to be a real pain in the butt. But you're going to get through it. You just got to kill the fractions off first and the brackets. So I'm just going to try and fix up the equation so that I can actually work with them. For the bottom one here, I don't want these brackets. So I'm going to understand that I can distribute the top because this is over 1 and that's over 1. So I'm going to have 3x plus 3 all over 5. And then 4y. And if I leave the negative on the outside, then this is just going to be 4 times 3. So negative 12 all over 5. If you had chosen to take the negative with you, that's fine, but then this would turn to a plus. Okay? And then 21 over 2. So just a lot of algebra things that could possibly go wrong. The next thing I want to do is I'm going to try to kill off my fractions. So I can kill off this fraction by multiplying the entire thing by 10, because 10 will kill off all my denominators. So if I multiply this by 10, or 5 times 2, then the 5 will cancel out. So 5 times 2, and then 5 times 2, and then 5 times 2. The 5s will cancel out, but the 2 still has to be applied. Same with this one, and same with this one. So then I'm going to have 6x plus 6 minus, I guess I can apply that, minus 8y plus 24, if I apply that negative with it. And then 21 times 5 is 105. So you can clean this up. You can move all the constants over to the other side. So minus 6 minus 24, minus 6 minus 24. So 105 minus 6 minus 24 is 75. So I have 6x minus 8y is equal to 75. And then over here, I also have to try and kill off these fractions, and I'm going to do that by multiplying by 15, or 5 times 3. 5 times 3, and you have to make sure to do it to the other side as well. So that means that this 3 will die, this 5 will die, and those ones both live because there's no fractions. So then I'm just going to apply the 5x minus 10 minus 3y minus 6 is equal to 30. And then I can add 10 and 6 to both sides to get 46. 5x minus 3y is equal to 46. So if you do this and you clean up your equations a little bit first, then you're not going to have to work with fractions later, which is a godsend. So please do some algebraic cleaning up. Kill your fractions, kill your brackets, and then you're going to have an equation here, and they are rearranged in the same way, and you can actually work with these. So you can choose to eliminate x, or you can choose to eliminate y by multiplying these equations. So I'm not going to finish that. I just wanted to show you that if you have fractions and brackets, you should get rid of them first to make the rest of the procedure way easier.